Fermentation is one of the oldest technologies in human history, predating agriculture by thousands of years. It was not originally conceived as a health practice, it was a survival strategy, a way to preserve food in environments where refrigeration was impossible and spoilage was a constant threat. The Greenlandic Inuit developed fermentation methods adapted to their specific environment and food supply, and those methods produce something that modern nutritional science is increasingly recognizing as important: a dietary source of diverse, beneficial microorganisms. Traditional Inuit fermentation was nothing like the kimchi or sourdough that has become fashionable in contemporary food culture. It involved burying whole or partially intact animal carcasses, seal, walrus, fish, seabirds, in permafrost or under rocks, allowing anaerobic bacterial activity to transform the proteins and fats over weeks or months. The resulting products, kiviak, Iginak, and other regional variants, are pungent to an extreme that most outsiders find overwhelming. But they were nutritionally significant in multiple ways. Fermentation converted some protein to carbohydrates, providing a rare carbohydrate source in an otherwise near-zero carbohydrate diet. It created populations of bacteria that colonized the gut, contributing to microbial diversity. And it extended the edible lifespan of large animals through seasons when hunting would have been impossible. The gut microbiome connection to overall health has accelerated dramatically as a research field over the past 2 decades. A diverse gut microbiome, one populated with many species performing many functions, is now associated with better immune regulation, reduced inflammatory markers, more stable mood and cognition, improved metabolic processing of nutrients, and lower risk for a range of chronic diseases. The traditional diet, across many cultures including the Inuit, naturally supported microbial diversity through varied, fermented, and seasonally rotating food sources. The modern highly processed diet does not. For contemporary readers, the practical application of this knowledge is more accessible than buried seal. Fermented vegetables, sauerkraut, kimchi, pickles made through lactofermentation rather than vinegar, provide diverse live bacterial populations. Kefir, both dairy and water-based, delivers high concentrations of beneficial organisms. Miso, natto, and tempeh offer fermented protein options. Aged and raw milk cheeses contain microbial populations that survive digestion in meaningful quantities. The research on which specific strains confer which specific benefits is still maturing, but the consistent signal across the literature is that regular consumption of diverse fermented foods supports a healthier gut ecosystem than a diet without them. A note of caution for those new to fermented foods: introducing them rapidly and in large quantities can cause temporary digestive discomfort, bloating, gas, altered bowel patterns as the gut microbiome adjusts. Gradual introduction at small serving sizes, increasing over weeks, allows adaptation without unnecessary distress. Individuals with small intestinal bacterial overgrowth or certain inflammatory bowel conditions should approach fermented food introduction under guidance, as the additional microbial load can initially worsen symptoms in these specific circumstances before it helps.